Hi, I'm Mr. Nawar. I'm a student teacher from OISE, and I'm here with Mr. P's Papapodcast. Today I will demonstrate supersaturation and crystallization. The three concepts we'll focus on today are crystal growth from solution, the properties of saturated solutions, and the idea that seed crystals must be of the same substance as the crystal that will grow. For this demonstration, the materials you will require include sodium acetate trihydrous, 50 grams, which will be placed into a 125 ml Erlenmeyer flask using a powder funnel. As your solvent, you will require 5 ml of deionized water. You will also require a scupula, a plate or petri dish on which to pour, tongues, a water bath, and a hot plate. Sodium acetate trihydrous is a skin and eye irritant, as indicated by STS. It is advisable when doing this demonstration to use chemical gloves and to wear goggles. So what I've done so far in terms of procedure is I've weighed out 50 grams of sodium acetate trihydrous and I funneled it into my 125 ml Erlenmeyer flask. I then added 5 ml of deionized water to act as my solvent into the Erlenmeyer flask. I found that some of the crystals stuck to the inner wall of my flask. So I took a squirt bottle filled with deionized water and I rinsed the interior to make sure that there were no crystals on the inside. This is crucial as these crystals may act as seed crystals and cause your solution to harden in the flask. This is not what you want to happen. I now will turn on my hot plate to about mid-heat and allow my solution to melt. What's important to note is that sodium acetate trihydrous, has water within the crystals, which allows those crystals to solvent in solution. I will then allow my solution to cool in my water bath. This can be done in several different ways. I can put it into a water bath or I can wrap it with aluminum foil and the foil will absorb the heat from my flask. Okay. As you can see, my solution has now come to a boil. I will turn off the hot plate and I will remove my solution carefully with tongs and place it into my water bath. The intention of the water bath is to absorb any latent heat of solution. It will assist my solution in its cooling process and speed up this process, especially when in class doing a demonstration. It is important to note that while the solution is dissolving the crystals, not to use a stirring stick, as the crystals will form on the stick and nucleation will begin, forming solid crystallized structures within your Erlenmeyer flask. As you can see, my 50 grams of solution have completely dissolved in my approximately 6 to 7 milliliters of deionized water. The cooling process will take approximately 5 to 8 minutes. I have now cooled my supersaturated solution in a water bath at room temperature. When your supersaturated solution has cooled, it is important to take seed crystals and put them into the petri dish on which you will pour your supersaturated solution. The seed crystals allow for the nucleation of a crystalline structure. So as I pour my supersaturated solution into the petri dish, you will see the formation of a crystalline structure. This occurs because the seed crystals are of the same substance as the solute in this water solvent. The reason I have cooled my solution is because Well, let's go back to the analogy of coffee and sugar. Hot coffee will dissolve more sugar than cold coffee, okay? The same premise applies. I had a hot solution and I dissolved a lot of solute in it. I cool it down and that solute now wants to come out of the solvent. And the seed crystals allow that to happen. So let's observe what occurs. Pour very slowly and carefully, as violent shakes will cause crystallization to occur in the beaker. And as you can see, my solute is quickly coming out of solution. If you were to touch the crystalline structure, it would be hot. This is an exothermic process. As the crystalline structure forms, stable bonds form, and the formation of stable bonds releases energy. This can also be used to explain thermodynamics in reactions. And there you have it, a crystalline structure of sodium acetate trihydrous. Cleanup for this demonstration is very simple. It is as simple as taking your crystalline structure and putting it into the stock beaker. The reason this is so simple is because this is sodium acetate trihydrous. Sodium acetate trihydrous is sodium acetate crystals mixed in with water. So when this hardens, it will form sodium acetate trihydrous, the same crystals that we originated with. Here's my crystal, and there's my cleanup. It is important to use gloves as sodium acetate is a skin irritant.